Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 5 and question number 6 of exercise 5A, Upthrust in Fluids, Archimedes Principle and Floatation, ICSE 9th Physics. The previous 4 questions have been done in the previous video, the link for which will be there in the description below. Do check them out, and if you like the video, consider subscribing to the channel and share it with your friends. Starting with the fifth question. So we have got two spheres A and B, each of volume 100 centimeter cube. So the volume of both of them are exactly same. That happens to be 100 centimeter cube. So I would write the given data here. VA is equal to VB is equal to 100 centimeter cube. Now when we convert centimeter cube to meter cube, we multiply by 10 to the power of minus 6. So 100 into 10 to the power of minus 6 meter cube. So this happens to be 10 to the power of minus 4 meter cube. So we have got the volume as 10 to the power of minus 4 meter cube. Are placed on water. So density of water is given as 1 gram per centimeter cube, and since I am doing it in SI units, I can write that as 1000 kg per meter cube. So I would write density of water. So I would write rho of water is equal to 1 gram per centimeter cube is given. So 1 gram per centimeter cube is nothing but 1000 kg per meter cube. The sphere A is made of wood and density. So density of wood is given as 0.3 gram per centimeter cube. So I will write rho of wood is equal to 0.3 gram per centimeter cube. When we convert to kg per meter cube, we multiply by 1000. So 0.3 into 1000 gives us 300 kg per meter cube. Now density of wood, we have got it as 300 kg per meter cube. And the sphere V is made up of iron. So iron's density is given as 8.9 gram per centimeter cube. So when we convert it to kg per meter cube, I would write rho of I is equal to 8.9 into 1000. So that would be 8900 kg per meter cube. So we have written all the densities here. Now we need to find the weight of each sphere. Now for finding the weight, we need the mass, because mass into acceleration due to gravity will give us weight. We would consider acceleration due to gravity as 10 meter per second square. So we know the formula, density is equal to rho is equal to m divided by v, that is density is equal to mass by volume. So from this formula, mass happens to be, I would be erasing this. So mass happens to be density into volume. So I would write that here directly. So for the first one, I would write MA is equal to density of A. Now density of A is made up of wood. So I would write rho of wood into volume of A. I hope it is clear. Since density is equal to mass by volume, so mass will be equal to density into volume. That is how we got this. I'll be substituting the values here. So volume of A, we got it as 10 to the power of minus 4, and density of wood is 300 kg per meter cube. So I write it as 300 into 10 to the power of minus 4. So we get it as 3 into 10 to the power of minus 2, because 100 is nothing but 300 is nothing but 3 into 10 to the power of plus 2. 10 to the power of plus 2, 10 to the power of minus 4 gives us 10 to the power of minus 2, and this is going to be in kg. Now we have got MA. Similarly, we will be finding MB, that is mass of B, that would be equal to, now B is made up of iron, so I would take rho of I into V of B. So rho of I, we got it as 8,900 into V of B, we know it as 10 to the power of minus 4. Now we can write this as 8,900 can be written as 8.9 into 10 to the power of 3 into 10 to the power of minus 4 remains as it is. So we get this as, this is going to be in kg. So we get this as 10 to the power of plus 3 minus 4 is nothing but 10 to the power of minus 1. So we get this as 8.9 into 10 to the power of minus 1, which is nothing but 0.89. So we get this as 0.89 kg. So we have got MB as 0.89 kg. Now we know the weight formula, that is, first we will be finding weight of A, that's going to be equal to mass of A into acceleration due to gravity. So mass of A happens to be 3 into 10 to the power of minus 2 into acceleration due to gravity happens to be 10. So 10 to the power of minus 2 and 10 can be written as 10 to the power of plus 1. Minus 2 plus 1 gives us minus 1. 3 into 10 to the power of minus 1 is nothing but 0.3 newtons. So we have got weight of A as 0.3 newtons. Now since the textbook answer is given in gram force, we can convert this to gram force. So for converting Newton to gram force, we multiply by 100. Please remember that whenever we convert Newton to gram force, we multiply by 100. So 0.3 into 100. So this gives me 30 gram force. So we have got weight of A as 30 gram force. Similarly, we would be finding weight of B. So I would write WB, that is equal to MB into acceleration due to gravity. Now MB, we know it as 0.89 into acceleration due to gravity, we consider it as 10. So we get it as 8.9 newtons. When we convert Newton to gram force, since the textbook answer is in gram force, we will have to multiply by how much? We'll have to multiply by 100 as we have done above, is equal to, we get it as 890 gram force. So we have got this as 890 gram force. Now we need to find weight on each sphere. We have already got it. So first part we have already got it. Coming to the second part, we need to find the upthrust on each sphere. So I would write upthrust on A, that is sphere A, will be equal to V rho G. Will be using formula. So V is volume of A into, Now remember, whenever we are finding upthrust, please do not take the density of the substance, take the density of the liquid in which it is floating. So we will be taking density of water here into acceleration due to gravity. Now V of A, we know it as 10 to the power of minus 4. Density of water is 1000. So 1000 can be written as 10 to the power of 3 into acceleration due to gravity is 10. So 10 can be written as 10 to the power of 1. So we get it as 10 to the power of minus 4 into 10 to the power of 3 plus 1 is plus 4. So we get this as 10 to the power of 0. So 10 to the power of 0 is nothing but 1. Any number to the power of 0 is 1. So we get 1 Newton. And when we convert this to gram force, we multiply by 100. So 1 Newton is our answer in SI unit, and in gram force it's going to be into 100. So that would give us 100 gram force. Now we would be finding upthrust on B. So upthrust on B is VB into, again it will be density of water on D into acceleration due to gravity. So VB is nothing but 10 to the power of minus 4 into density of water is 1000 kg per meter cube, which can be written as 10 to the power of plus 3 into acceleration due to gravity is 10, which can be written as 10 to the power of plus 1. So we get the same values again. So 10 to the power of minus 4 into 10 to the power of plus 4, which is nothing but 10 to the power of 0, which is nothing but 1 newtons. And when we convert it to gram force, it is 100 gram force. Now that we have got upthrust also, we need to find out which sphere will float. So we need to find out which sphere will float, give reason. Very simple this is. For the sphere A, the density is 300 kg per meter cube. So I can write, since density of wood, that is for sphere A, is less than density of water, that is 1000. 300 is definitely less than 1000. So this means that sphere A will float. Sphere B will sink. The reason is the density is more than that of water. So I hope this question is clear. Was a slightly tricky question, I would say. So getting into the next question, that is question number 6. So for question number 6, we would be writing the mass of block made of a certain material is 13.5 kg. So I would be marking this. Mass is given as 13.5 kg and its volume is given as 15 into 10 to the power of minus 3 meter cube. So volume is 15 into 10 to the power of minus 3 meter cube. We need to calculate upthrust on the block if it is held fully immersed in water. So we need to find the upthrust of the block if it is fully immersed in water, and then we need to find, will the block float or sink in water? Give reason for your answer. So again we need to find what will be the upthrust on the block while floating. So coming here, calculate the upthrust. So for finding the upthrust, we can use the formula V into rho into G. So I would be writing the given data, that is mass is given as 13.5 kg, 13.5 kg. Volume is given as 15 into 10 to the power of minus 3 meter cube. Now when we find the upthrust, we will have to take density of water. So rho of water, I'm not writing it again. Density of water is given as 1000 kg per meter cube. So for finding the upthrust, we will be using V rho G formula. But do we have the volume? Yes, we have the volume. So here I will be writing upthrust. Upthrust is equal to V into density of water into acceleration due to gravity. So volume is given as 15 into 10 to the power of minus 3 into density of water is 10 to the power of plus 3, because 1000 can be written as 10 to the power of plus 3 into acceleration due to gravity is 10. So 10 to the power of plus 3, 10 to the power of minus 3 cancels. So we get this as 150 newtons. So we have got the upthrust as 150 newtons. Since the textbook answer is given in kgf, we can divide this by 10 to get it in kgf. 0, 0 cancels. We get this as 15 kgf. After finding this, will the block float or sink in water? So we will come back to this. A very simple way to find whether it will float or sink is to find the density. So I can find the density of the block. Let's say I would write density of the block, let it be rho. So density is equal to mass divided by volume. So yeah, so mass is nothing but 13.5 divided by 15 into 10 to the power of minus 3. 10 to the power of 10 to the power of minus 3 goes to the numerator and becomes 10 to the power of plus 3. So we get 13.5 into 10 to the power of plus 3 divided by 15. Now we get this as 13,500 13500, because 13.5 into 10 to the power of 3 gives me 13,500 divided by 15. Now 135 is divisible by 15, so that is 9 times. So we get this directly as 900, and it will be in kg per meter cube. Now as we can see, density is less than density of water. That means it will float. So this is the easiest way to find out whether it will float or sink. what will be the upthrust on the block while floating? Now, if a body is floating, we need to remember that upthrust will be equal to weight. This happens only when the body is floating. So upthrust will be equal to weight. So weight is nothing but mass into acceleration due to gravity. So mass is 13.5 into acceleration due to gravity. We will take it as 10. I would write it here considering g is equal to 10 meter per second square. So we get this as 135 newtons. So that would be our upthrust on the block while floating. Or if we convert it to kgf, we need to divide it by 10. So 135 divided by 10, so that is 13.5 kgf. So I prefer doing all the numericals in SI units, because in your exam the answer will not be given as in the case of your textbook. So you never know whether the examiner wants you to get the answer in SI unit or in some other unit. If it is specified to get in any other unit, I would definitely do it in that way. But since it is not specified to get it in any specific unit, I do it in SI unit. And then it's very simple to convert here. When we are converting Newton to kgf, we divide by 10, and when we are converting Newton to gram force, we multiply by 100. So this completes this video. Question number 7 onwards will be there in the next video, the link for which will be provided in the description below. Do check that out, and if you happen to like the video, consider subscribing to the channel and share it with your friends. Dhanyavad.